All available experts, please report to room A9.
Hello guys, Hector here. Today I should be going over the module Basegate. So before we get started on this, I'm going to go down to here to get the socket and K values, which will be useful for this step up here. The first time the grid is used, talking about this grid up here, we're going to be looking at the top socket, which is what the switches are connected to. So our first colour is purple, or magenta as it's referred to. And K is the number of batteries, which is 2. The second time the grid is used, when we look at the right socket, which is, I think that is yellow, which is, and then K is the number of indicators, which is 3. And the last time the grid is used, if the number of cell or more modules is even, which is not, so we're going to be using the left socket. The left socket is green, and K is the number of ports, which is 2. And now going back up here, find the row of the top switch's colour on the left in the table below, so that will be white. And we're now going to find the colour of the bottom switch, which is yellow here, to follow it up to get an instruction, which is this. We're now going to find our socket colour in the same row that was magenta. We'll go forward K times, so 1, 2. And now we're going to follow this rule. Rotate the position in the grid 90 degrees clockwise. So clockwise is around to this way, so this will move up to here. This is our first colour, and we're going to note that down. We're now going to do this with the left and the right one, so the left switch is white, the right is...
Emergency cleared. All personnel, please return to your stations.
The right is red, so we get the up this time. And then in the same row, we're looking for yellow this time. This is the second time we're using the grid. We're looking for yellow, and we're going to move forward 3 times. 1, 2, and then looping back up to the top. Living extra in this area, basically. But the top row is adjacent to the bottom row. And then we're going to apply this rule, which is with n spaces up where n is the first digit of the serial number. The first digit of the serial number is 6, so 1, 2, 3, 4, 5, 6. So our second colour is yellow. We're now going to use these 2 colours for our third set. So green, yellow, so we're going to get left. And then finding green in this row and moving forward 2. We're going to apply this rule, which is move n spaces left where n is the last digit of the serial number. The last digit of the serial number is 6, so 1, 2, 3, 4, 5, 6. We have B, and this is our final colour. Concatenate the numbers. We're going to come down here, concatenate numbers, the serial number, into one number, keeping it leaving zeros. So our number is going to be 66. And modify it using the final colour. So using blue, we're going to multiply the number by 3. 66 times 3 is 198. This is going to be our final calculation number. We're now going to submit that number in binary, ternary, and quaternary, where the binaries could be the switches, the hatches are going to be the ternary, and the diodes that will fit underneath the switches, the hatches, are going to be the base 4, or quaternary. So let's start with switches. First we're going to come down here. How many serial number valves do we have? We have 1. This is I here, which is an odd number, so we're going to be using this side. We're going to use the final colour, which is this, blue. And the M's and L's refer to, big M is the most significant digit, second most, second least, basically. And we're going to point them in the direction of the corner of the module with that required number. So, first we're going to calculate the number by 16, So 198 mod 16 is 6. So we're going to be doing 6 in 4-digit binary, which is 0110. So the M here has to be 0, which it is. The next one is here, and this needs to be a 1. So it's been put towards 1, so it would be this side. Then we have the second least, which has to be also a 1, so it's pointing in the right direction because it's pointing to this corner. And finally, the least significant digit has to be a 0, so it is in fact pointing to a 0 corner. So we've set the switches now. So ternary is now the hatches. We're going to modulate the number by 27 this time, which gives us 9. 9 in ternary, in 3-digit ternary, is 1, 3, and 9. So it's going to be 1, 9, or 3 squared, plus 0 plus 0. Technically 0 3s and 0 1s. We get 9. So we're going to be 1 0 0. Use the fourth character of the serial number along the top. We've got T, which is in this range, and the fifth along the side, I, which is in this range. So this is the grid we're going to be using. The most significant digit, which is represented by this M, is a 1, and the other two are zeros. This is the second most significant, and this is the least significant. So we're going to be using these three handles, which reveals the dials. We're going to modulate our current number by 64 this time. We have 6. So 6 in quaternary is 0 4 squareds plus 1 4 plus 2 1s. So it agrees to me 0 1 2. So if the values of k were in the first order were all different, they were not. So we're going to be going in reverse reading order. So this is the most significant, followed by this one, followed by this one. So what do we know? How do we know which direction represents which number? To show the values of the cardinal direction, we'll find the number of pointers on the bottom, which is 1 in this case. But the number of letters in the serial number, that is 4. What do 12 is still 4, add 1, we'll get 5. Turn the dial in the direction that's closest to this number on a clock face. So with 5, that's closest to downwards of 6. That could be a 3. So this would be a 3, and then going clockwise, this would be 2, this would be 1, this would be 0. So our most significant digit down here has to be a 0. So 3, 2, 1, 0. This one has to be a 1. So 3, 2, 1. And this one has to be a 2, 3, 2. So now we set all three of them, the digits, we can press the button in the top corner, and we get a module. So just to recap on how this module works, we find our socket and K values from here. Use the top switches colour on the first set, left on the second, to add the bottom and right ones respectively. Hold on, let me reword that. Then we use either the top and bottom or left and right to find a colour on the right, which will find another colour in the row to get an instruction, which will apply to the socket and K values from here until we get a final colour after using the found colours. Then we concatenate the numbers in the serial number and modify them using one of these rules to get our final calculated number, which will submit modulo 16, 27, and 64 using our calculated colour and the given rules, where the binary is the switches, the ternary is the hatches, and the quaternary is the dials. So hopefully you understand how Basegate works now, and I'll see you guys in the next tutorial.